Hi everybody, continuing our series of videos on Calculus 2 by example. Today we're going to start talking about integration techniques or techniques of integration. All right, so the first one we're going to look at is called basic substitution, but we're going to actually start by going back and looking at a derivative rule. We're going to start by looking at the chain rule because basic substitution, or it's sometimes called U substitution, is largely about reversing the chain rule. Not in every case, or at least not obviously in every case, um, but generally this is how you want to think about it. So the chain rule says that if you're going to take the derivative of a composition of two functions, if you're taking the derivative of f of g of x, it's f prime of g of x, and this is how quickly the function f is changing with respect to the function g, multiplied by how quickly the function g is changing. So for example, if I take the derivative of arctangent of x squared plus 7x, so this is a composition of two functions, it's the derivative of arctangent, which is 1 over the input squared plus 1, multiplied by the derivative of x squared plus 7x, which is 2x plus 7. And so this is the result. And we could do a little algebra and maybe try and clean that up, but that's the answer. Okay. So this is the chain rule. And what we want to do with basic substitution is learn to sort of recognize when our integrand is the result of this process and work backwards. Okay. So here's an integral. Here's an indefinite integral. And looking at this, I could recognize that in the denominator, I have a cosine, and the derivative of that is negative sine. And I have a 14 theta, and the derivative of a linear function like 14 theta is a constant. So the numerator kind of looks like it could be the derivative of the denominator. So this is similar to what we were looking at. So I'm going to introduce a new variable called u, and I'm going to let u equal 14 theta plus 2 cosine theta. Taking the derivative of this, I get that the differential of u, the change in u, is 14 minus 2 sine theta. Derivative of 14 theta is 14. The derivative of 2 cosine theta is negative 2 sine theta, multiplied by d theta. And that's actually all multiplied by d theta, which is the change in theta. Okay, this isn't exactly the numerator, but I noticed that if I factor out a 2 here, then this looks like 2 times the numerator times d theta. So I'm going to go ahead and put that 2 in there, but I'm also going to put a 1/2 on the outside because this keeps my equation or my expression balanced. Because I'm multiplying by the 2 and the 1/2 at the same time, I'm not really changing anything because 1/2 times 2 is 1. Now I'm going to start making some substitutions. The 14 theta plus 2 cosine theta is equal to u. And the 2 times the quantity 7 minus sine theta, d theta, is equal to du. So I can make the substitution that the denominator gets replaced with u, and the numerator, including the d theta, gets replaced with du. Okay. Now I have an integrand that I could actually find the indefinite integral of. Okay. The antiderivative, or indefinite integral rather, of 1 over u is the natural log of absolute value of u. And then I have a plus c because this is an indefinite integral, and that represents all the possible antiderivatives. I don't forget my 1/2. Be careful to make sure that that constant multiple gets carried along from one line to the next, just because I know that it's really easy for those to get lost. I've been teaching this for a while, and I know the sort of mistakes that students commonly make, and constant multiples sometimes wander off on their own and get lost. Okay, I can now substitute back. So I know that u is 14 theta plus 2 cosine theta. And so the natural log of absolute u becomes natural log of the absolute value of 14 theta plus 2 cosine theta. And that's our indefinite integral. Okay, So that is basic substitution or U substitution. There are some examples of this that are a little more complicated or a little more clever, but they all work around the same general principle. Okay. In the next video, we're going to look at something called trigonometric substitution, which is a lot more clever and subtle. And so I will see you then.